Okay, everyone. Uh, we already end our first chapter. Okay, so if you have any doubt regarding your first chapter, all of you please come up with that, or we will go to the next chapter. Okay. If anyone have any doubt up to the last class, please ask. Okay. Anyone have any doubt? Please respond, or else we will go to the next sub chapter. Okay.
Okay, sir.
Can we move to the next chapter, or if you want to ask anything regarding your first chapter, whichever we have done till now.
Okay.
Please respond, all of you. Okay, then we will move to the next chapter. Okay. Okay. So our next chapter is okay. We will go move to the next chapter. Our next chapter is moving loads and influence lines. Okay. So this is our unit two, moving loads and influence line. So I think all of you know we have basically two loads. Okay, dead load and live load. So whichever we have calculated till now in your earlier semester also, we always do for the live load. So for this chapter, we need to consider in the earlier we consider only the dead load, but for this chapter, we need to consider also the live load. As all of you know, live load it's not the fixed load, it is moving. As live means it have a life, so it is moving. As you can say, for example, in the bridge, all the vehicles are moving, so it will give a load on the bridge, but it is not permanent or it is not fixed. This loads may be different as per the vehicle moving on the bridge. So we need to we need to analyze this type of load. So as per the live load, what is the effect on any particular structure? So how it is affect the structure? What will be the structure of SFD, BMD? What will be the calculation? How we need to move? So these things we are going to discuss in this chapter. Okay, as you can see, there are two types of load: dead load and live load. In all our previous analysis, what we do it only for dead load, but here, in case of moving loads, say in road bridges, the position of load continuously changes, so we need to check how the effect comes from this type of load. Okay, So we need to calculate shear force, bending moment, everything. And finally, we need to draw the ILD. ILD means influence line diagram. Okay. So here there is a basic, see there is a, okay, this is a simple introduction part. What is this? Basically, ILD means, okay, moving loads. I think all of you understand what is moving loads. So what is this ILD? Means influence line diagram or influence line. So when applied load is not fixed, that is moving, we use influence lines to determine the impact of live moving loads at a single point as the load moves across the brief. So influence lines are important in the design of structures that resist live moving loads, such as you can say breach and all these things. Okay. So common sense tells us that when a load moves over a structure, the deflected shape of the structure will vary as per the load moves from each point, from the starting point to the end point. So it will not fix. Okay, it is not exactly same. It may vary as per the load. If it is say even a bridge, if a vehicle is moving from one side to another, so as per the movement of that vehicle, the load varies. If the vehicle is at the starting, the vehicle gives a load at that point, not in the other point. Similarly, if the vehicle moves slowly from each point to the another, the load also move from each point to another. So we need to analyze that move, how it is moving the load, how it move in that structure. So in the process, we can arrive at simple conclusion that due to moving load position on the structure, reactions value at the support also will vary. I think all of you understand this, because if the load is moving from one to another, we simply say that the loads, as per the load, the reaction, all the shear force, all the bending moment will also vary. So, from the designer's point of view, it is essential to have safe structure which doesn't exceed the limit of deformation and also the limits of load carrying capacity of the structure. So, all of you know this. We need to design or we need to analyze any structure as per that load. We are considering any load. We need to consider some load as per the load we are going to design a structure. So, by so that that structure doesn't fail. So, what is the definition? So, all of you please go through this. There are so many definitions as by different researchers. So there are some definition. So here you see an influence line is a diagram whose coordinates, which are plotted as a function of distance along the span, give the values of an internal force, a reaction, or a displacement at a particular point in a structure as a unit load move across the structure. Okay. So this what it basically says that as per the time, as per the distance, the load is moving through a structure. So as per that, our force, our reaction, our displacement, everything will vary as per that load. And this influence line diagram is nothing but the representation of this type of movement of load. Okay. So next definition is a influence line is a curve, the ordinate to which at any point equals the value of some particular function due to unit load acting at that point. So when we analyze such type of load, we always consider a unit load. Okay, we are considering as by considering a load of value unit 1. So this is important thing. Okay, all of you please remember this. You may get question in your exam. So when we are doing analysis for ILD, so when we do analysis for ILD, what load we need to consider, or what are the load, for which kind of load we are considering for doing analysis of this structure. So always remember that we are considering always unit load, because if you can, if you resolve any force, if you analyze, if you derive, if you calculate any structure by considering unit load, we can easily say that if we can, if you know the calculation for unit load, if someone say, okay, now you do for 50 kilonewton load, so simply multiply by 50, you can easily say that this mass of load will come. So when we resolve any structure by considering unit load, so it is very easy for us to say for any kind of load. So always remember that first we always analyze the structure by considering a unit load. Unit means one. Okay, considering as a one. Any load, say 1 kilonewton, 1 newton, 1 ton, like that. Okay, so we considering always one as a unit load. Okay, next, a influence line represent the variation of either the reaction, shear, moment, or deflection at a specific point in a member as a unit concentrated force moves over the member. Here also it is saying same thing. So it is nothing but the representation of that reaction, shear, moment, every deflection, everything what will come as in a structure by movement of that load. So for that calculation, we always consider that load as a unit load. Okay, fine. So what sorry. So why do we need this influence line? So when loads pass over structure, for example, a bridge, one needs to know when the maximum values of shear, reaction, bending moment will occur at a point so that the section may be designed. This is the basic reason why we need to know this influence line, because by knowing this, we can easily say at what point in the structure, what are the circumstances of that load, bending moment, shear force will occur at which position, and what is the structure will look like, so that we can design according to that. Okay, so there are two ways of construction of influence lines. One is tabulated value and one is influence line equation. Okay, we'll discuss about this in the this is simple as just basic introduction about this influence line. So here you see how we need to find out this influence lines. There are some procedure how we need to follow, how we need to go one by one, step by step. So here this is the procedure as per the tabular values. There are two approach. One is tabular value, one is influence line equation. Okay, when we follow the tabular values, how we need to move, and we'll discuss in the later part how we need to go through the equation as per the equation. So here you see, first place a unit load, a load whose magnitude is equal to 1 at a point x along the member. So what it is saying, if you consider say a beam, okay, along that beam, let me show you this. See here, here, this beam. If you consider this beam AB, this is a simply supported beam. If you consider a unit load, this, I think all of you are able to see at a distance x. Okay, we are considering at a distance this at a distance x. Okay, so at a distance x, if you consider a unit load, first we need to consider a unit load at a distance x. Next, what use the equation of equilibrium to find the value of the function reaction, shear, or moment at a specific point P due to the concentrated load x. So what is this equation of equilibrium? Can anyone say me what are the equation of equilibrium? Anyone please respond. What do you mean by this equations of equilibrium? Have you got this in earlier sem? Okay, fine. Let's go through this. For this, please go through these notes. Okay. There are two type of structure. We know there are two types of structure. One is determinate structure and one is indeterminate structure. Okay. So what is this basically determinant and indeterminate structure? So here you see this definition. These structures or members which we can analyze just by using the basic equilibrium equation is known as determinant structure. So it is simply when we use the simple basic equilibrium equation. If we using that equation to solve any structure, if we are able to solve that, then we can say that this structure is a determinant structure, or it is simply opposite for in terms of indeterminate structure. If we can't solve by using that basic equilibrium equation, we can simply say that this is a indeterminate structure. For example, you see it is given simply supported beam, cantilever beam, and for indeterminate it is continuous beam. Because it is continuous, it is not ended in its particular position, so we can't solve that by using this three equation. Okay, so these are the main important things. Please remember, for solving this numerical and for this, we always remember these three equation: summation of h equals 0, summation of v equals 0, and summation of n equal 0. This three is the basic equilibrium equation. I think all of you got this in your earlier semester also. What is the summation of h, summation of v, and summation of m? This is nothing but summation of h means the horizontal force acting on a particular structure. If we solve that, that will be give you the summation of horizontal. Similarly for vertical force and for moment, okay, summation of m. So we need to use these three equations to solve, to find out this. The second step, use the equation of equilibrium to find the values of function, reaction, shear force, everything at any point, okay, in the beam or in any structure. So we need to repeat these steps in the whole section. Say in here I have say that we are considering at a distance x, so we need to move this load. Now we are considering at a distance x, so again we need to move this load in the whole over the beam. Similarly, like here, like here. So we need to solve this, okay, by considering as unit load in every point. Okay, fine. This by influence lines equation. It is simple, same as it is earlier it is explained. Just we need to use that equation. There are some equation. I will tell you what are the equation while we solving a numerical and all these things. So this is the same step. Again, we need to consider a point at the distance x. Then we need to move along the member from one point to the another, from the starting to the last point. So we use the equilibrium equation to find out the reaction, shear force, moment, and all these things. After finding all these things, we just need to put the value as you draw in the earlier SFD BMD. Okay, simply we need to draw that. See, this is how we have to derive. Influence lines can be constructed by deriving a general mathematical equation to compute parameters like reaction, shear, moment at a specific point under the effect of moving load at a variable position x. So this is a numerical example. Okay, just see, just a simple numerical example. Here we are considering what? We are considering a beam AB, oh, okay, of span 10 mm. So we need to construct a influence line for this. So for that, what we need to do, as you see, construct the influence line for the reaction at support B for the beam of span 10 mm, 10 meter. The beam structure is shown in figure in the below. Okay, so we need to find out the reaction at B. So we'll move one by one. So here you see, for this same numerical, we are going to solve by the two method. Okay, there are two ways, as you can also already I have explained, tabulated, and the one is influence line equation. Okay, here you see, a shown in the figure, a unit load is placed at a distance x from support A. Here you see a unit load. This is load is applied at a distance x from the support A, and the reaction value RB is calculated by taking moment with reference to support A. So I think all of you know how we need to find out the reaction. Is it? Do you know how we need to find out reaction?
Yes,
If
sir.
we need to find out, if we need to find out reaction at B, how we need to find out? By considering the moment to the support A. It is very
Yes.
simple. I think all of you know. RB into the whole span minus 1 into 2.5 into 0. So from this you can easily find out this RB. Okay, here why 2.5? It is saying that, let us say if the load is placed at a 2.5 meter from support A, then the reaction RB can be calculated as follow. So I think it's very easy. I think all of you know this. How do we need to find out this? Next, here you see how we need to form the table. Similarly, the load can be placed at 5 meter, 7.5 meter and 10 meter away from support A, and reaction RB can be computed and tabulated as given below. So simply you follow this calculation RB, how we are taking that moment along the about A. So now first we consider that load is at a distance of 2.5 meter. Again, you put that load at 5 meter, 7.5 meter and similarly up to 10 meter. By simply going that, you just calculate these things. Okay, RB. And you see one thing, always remember, when I consider a unit load from in a section from one part to another, as you can see here, at the beginning 0, see at the beginning 0, you will get reaction as 0. If you calculate like this also, if you place this unit load at point A, you will get this RB as 0. Okay, just calculate this. Are you able to get it or not? This RB as 0. And simply you say, when you put at the last point 10, at the last point of the section here, at the point B, when you put that, you will get always as 1. Okay, so remember this step. When you start from a point, you will get 0. When you end at a point, you will get 1. If you are not getting this, means your calculation is wrong. Okay, so remember this. So after getting this, if we plot the graph, or if we draw the ILD, how it look like, see here, graphical representation of influence line for RB. You see, from 0 it will comes up at 10. This is for RB, reaction RB, considering about the moment, or sorry, about the point A. You see, from 0, 2.5, 5, 7.5, 10, how the values are coming. Okay, and RB is nothing but it's simply after calculation you will get x by 10. If we consider x 0, you will get 0. If we consider 2.5, just calculate it. Similarly, up to 10, 10 by 10, you will get 1. This line is give you 1. Okay, here it is written 1. Are you able to see this? Is it visible to you?
Yes, sir.
Okay. Are you able to got it? Are you able to got it? All of you, please go through this once. I am repeating again. Please check. This is your line. This is your beam AB. We need to construct the influence line at support B. Okay. At support B, we need to draw this influence line. This is your influence line diagram at reaction at B, at support B. So for that, what we need to do, we need to first calculate this reaction RB. What is the reaction? By considering at a distance, at different distance from 0 to 10. If we go from A to B, if we start from 0 to 10, just calculate the reaction by considering 0, 2.5, 5, 7.5, 10. It's not like that. You can also calculate at 2, 4, 6, 8, 10 also. Okay, it's not like that. You need to consider only 2.5 interval. It's up to you. As at every one interval also you can calculate. Okay, this table you can also make it at every one interval also. This x value you can also use as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, also 2, 4, 6, 8, 9, 8, 10. Similarly, but keep the interval as same. Now here we are taking at 2.5 interval, but you can also take 1 meter interval also, 2 meter also interval also. Okay, just keep the interval same so that your drawing looks good. Here you see. Any doubt in these steps? Please respond.
No, sir.
Are you able to got this?
Yes, sir.
Fine. Is it okay?
Yes, sir.
I think it's very easy. Just simple. You need to calculate the reaction. Okay, fine. What is our next step? So what using inference line equation we will discuss in the next. Okay. Anyone have any doubt up to this? I will share this. Okay, I will share this with you. Don't worry. I will give you these PPTs. Okay, let's stop here. Okay, I will discuss the next part in the later in the next class, or it will be confused. All of you, please give your attendance. And if you have any doubt, please ask me. Okay.
Okay, sir.
Is it clear? Which I have taught now.
Yes,
This
sir.
basic part,
Yes, sir.
because later on we need to solve a little bit complicated one. Okay.
Okay,
But
sir.
the procedure is same. Don't worry about the procedure. This procedure is we need to follow only. This is the simple procedure we need to follow. Just remember, we need to consider always unit load. These are the main things for this chapter. Always remember that we need to consider a unit load at any particular distance. By considering that unit load, we need to resolve the force. Sorry, we need to find out the reaction. Similarly, if there is horizontal force, vertical force, we need to resolve. After that, we need to resolve the moment. After doing all these things, finally, we need to draw the inference line diagram. Okay.
So what if we don't consider unit load, sir?
But Michael.
So what if there's some questions? What if we get questions like we did in previous semester where we don't consider unit load? Maybe we have load of 20 kilonewton on a 40 kilonewton.
No, no.
Can we,
You see, when we solve any particular section or any structure by considering dead load, okay. For that, you need to consider any load. Similar, say in your previous sem, you have got I think 20 kilonewton UDL, 20 kilonewton point load. So for that particular load, you have calculated only for that point when where the load is given. Okay, you no need to shift that load in that particular section. When you solve a beam, say in a simply supported beam, if a point load is given, when you solve in that type of beam, what you did, you solve that beam by considering that load in that particular point only. Is it
yes, sir.
okay? But for this chapter is what, this is influence line diagram for moving loads. Okay, as these terms moving loads, it is well explained that moving load means what, it must be moving, it will not fix at a point. Okay, it will not fix at a point. For moving load we can't do in a particular point only. So we need to consider the whole span. Say in a bridge, we need to consider the whole bridge, how a load is moving from one point to that another. Okay, so how we'll come to know that for that particular point what is the effect. Say a bridge is given this a span of 100 meter. Okay, for that 100 meter span, if a truck is moving from a point to b, how can we say that at point a what is the effect of that truck, at point b what is the effect of that truck, similarly at the last point what is the effect of that truck. So we need to move that load from one point to another. Okay, say in this derivation what I have said, for a particular distance x, so that distance it must be it may be anything, any distance. Okay, at 1 meter, 2 meter, 2.5, any distance you may consider. So by considering that distance, what we need to do, we need to resolve, we need to analyze what is the effect of that load in that whole section or in the whole span of that structure. So for that, for our easy calculation, what we consider that load as unit load, so that our calculation will not be complicated. If you consider a unit load, our calculation is little bit easy to calculate. Okay, but in some question you may get that in case of unit load you may get 20 kilonewton. So but in that case you need to consider in place of that one, you need to consider that 20. Okay, so if we know how to do for a unit load, you can solve easily for any kind of load. Is it okay? Is it clear to you now, Michael?
Yes, sir. Yes, sir.
Okay, thank you. Also, you go through once through the notes. If you have any doubt again, you can come with that. Okay, I will clear it out. All of you, please stay for a while. I will mark your attendance. Okay, I need to write it down. This, please stay for a while. Okay, is there anyone left to give the attendance?
Sir, what about Bhuvan? 082.
One roll number is 82, is it?
Yes, sir.
Okay, I have given to him.
Okay.
For Abu Taleb also I have given. Tashika Mara I have given. Okay, fine. Anyone else? Okay, fine. Okay, thank you then, all of you. Have a good day. We will see you in the next class. Okay, thank you all.
Okay, sir. Thank you, sir.
Thank you, sir.